Okay, so today we're going to talk about solving quadratic equations, just like we've been doing before, with one exception. Or one difference, I'm sorry. We're going to be using square roots to solve them. In essence, the type of problems that we are going to be doing are ones that are missing the C. So equations with no C. Right? You've got ax squared plus bx plus c. Oh, what am I saying? With no b, sorry. What am I saying? With no b. Glad I wrote that up. Okay, with no b. We're going to be missing that, okay? And we're going to say it's equal to 0, right? An equation. So the first example would be x squared minus 25 equals 0. Now, the way we know how to do this right now, right? The way we know how to do this right now, sit in your seat.
Why?
Sit in your seat during the lecture, because it's just too complicated.
But why?
Sit in your seat during the lecture. Come on. So, the way we know it right now is difference of two squares. Am I right? Am I right? Difference of two squares. So we would just say, well, it's x plus 5 times x minus 5 equals 0, right? You guys all remember this, right? And then you say, well, either x plus 5 equals 0 or x minus 5 equals 0. Subtract 5 from both sides, you get x equals negative 5. Add 5 to both sides, you get x equals 5, right? And you put the word or in the middle, and that's your answer.
Yes.
Right? That's easy, right? Now, but sometimes they're not written like this. Sometimes this is the same problem, only I'm going to write it differently. X squared equals 25. Do you see how that's the same thing? So Caleb, you really need to pay attention right now because you're not going to understand anything if you don't, right? I'm starting simple and it's going to get harder, so please pay attention. So does everybody see how those are the same? They look different, but all I did is, what did I do to this to get to that? All I did is add 25. Don't you agree with me? Yes?
Yeah.
Right? I added 25. So now I have x squared equals 25. So there is a cool process using square roots. I notice this is x squared. Is that a perfect square?
Yeah.
Can I take a perfect square root of x squared? Yeah. What is it? It would be x, right? Right? You've got a perfect square. Here's my perfect square. Beautiful square. Here. Right? Perfect square. This is x. This is x. So my area is x squared. The square root of x squared is one of the sides of the perfect square. It's x. Right? So what I'm going to do is I'm going to square root. I want to know what x equals, right? So I'm going to just square root my x squared. Tom, have a seat here so they can see. But if I square root the left side, I have to square root the right side. Do you agree with me?
Yeah.
Whatever I do to one side of an equation, I have to do exactly the same thing to the next other side. So what's the square root of x squared? X. What's the square root of 25?
5.
Almost. What times what equals 25? What are all your possibilities? 5 times 5, I agree. So 5 is one of them. But what else could be times itself to give you positive 25? Say what?
1 and 25.
It's got to be square root. It's got to be the same number. What about negative 5? Is negative 5 times negative 5 25?
Yeah.
Oh, so this is weird because typically you've been taught that the square root of 25 is 5. But when you're dealing with quadratics, meaning it says x squared, right? There's a special thing you have to take into consideration, that this one could be positive or negative. Because the square root of 25 could be positive 5, or it could be negative 5. Does that make sense? So look, that explains why we get the same answer now by doing that. Does that make sense? You see that?
Yeah, really.
Right? And so the way you would write it, though, is this. Get in the habit of doing this. Plus or minus 5. Okay? That's a little shortcut, and you're going to start to see that a lot.
So is that what we're doing tonight?
That's what we're going to be doing today. It's easy. It's really, really easy. I'm going to make it a little harder, but even the hard ones are easy, right? I'm assuming I'm all on the board. Hope I am. Looks like I am. Okay. Just make sure. Okay. All right. So let's try a few. Let me just get my paper so that I can see. Where did I put it? There they are. Okay. So let's say I gave you. Let's try an easy one. That was number 1. Here's number 2. Number 2 is not on the. Here's number 2. Okay. How about I give you x squared equals 100. I square root both sides, right? Now what do? I got x is equal to what?
Oh, positive 10 or negative 10.
Plus or minus 10. Easy, right? So easy. Okay, now we're going to make it slightly harder. How about I gave you 4x squared equals 100. Now, I could take square root, but you don't want to do that. You don't want to take a square root on this side unless it just says x squared. Okay? So we're not going to take a square root yet. We always want to get the a equal to 1 if we can. How would I make a 1? Divide by 4, right?
So then we have x.
So then now we have x squared is equal to what? 25. Now it says x squared equals. That's great. So now we're going to do square root of x squared, square root of that, and I get x is equal to what? Plus or minus 5. Easy.
9.
Easy, right? Easy, easy, easy. Okay, so let's go do some more. All right, 2, 3, 4. All right, what if I gave you, what if I gave you this? What if I gave you 16x squared equals, 16x squared equals 25.
Oh, I know. No, I really don't because. Wait.
So remember, we don't want to really square root this with the 16 in it because we wanted to say x equals, not 4x equals, right? I mean, we could. It would just be a little longer. But I think this is what I would do. I would divide both sides by 16. You with me? And then this is what I have. I have x squared is equal to 25 over 16. Yes?
Does that count?
Well, we're almost. Now we got to do the square root, right? When I do the square root on this side, I get x, right? When I do the square root of this, what do I get? This is the same. This is the same as the square root of 25 over the square root of 16.
Wouldn't it just be plus or minus 5 over 4?
You got it, exactly. Does that make sense? Do you see that?
Oh, you just get each individual.
Because these are both perfect squares, so I would just keep them as perfect squares. You know, take the square root. When you take the square root of a fraction, it's the square root of the numerator over the square root of the denominator. It's the same thing. These two are identical. Does that make sense? Remember this?
Yeah.
Okay. So, all right, that was 4. Let's see, 5. What if I gave you 3x squared equals 48? What would you do?
Oh, I know.
Micah.
Okay. Well, you do it by 3.
Divide by 3, right? Divide by 3. And then I have x squared equals, anybody know what that is?
No.
3 goes into 4 how many times?
Once.
Once. How many is left over?
1.
1. So I'll put that in front of the 8 to make 18. 3 goes into 18.
6.
6. Oh, it's 16, which is a perfect square. Good.
Yes.
Okay. So now, Micah, what do I do now?
Well, you do the little thing, the sign over
Square
each
root.
one. Square root.
Right? Square root. Use the words square root. Now what do I have?
And then you have x plus or minus 16. 4.
Yeah, there you go. Beautiful. That's your answer. All right, what if I gave you, what if I gave you something like this? 4x squared plus 10 equals, equals 6. No, equals, equals 26.
Okay, well you do minus 26. Right? Minus 10.
Can you just square it?
Well, wait, I want my x's
Oh, wait, no, you have to divide.
alone. I don't want this here, right? This is okay. I want things on that side, but I don't think I want this.
Minus 10.
So minus 10,
And then
minus 10,
that's 4x squared.
4x squared equals 16.
And then you do the square thing. Wait. No.
First, I
Yeah, you
want it to
divide
say
4
just x squared before I
by
do that.
4.
Divide by 4, right? You guys all with me? Does it make
Yeah,
sense?
and then it's x squared.
X squared is equal to 4.
4. And then you do the
Square root, what's my answer?
X is plus or minus 2.
2. Beautiful. Excellent. Just a 5. You guys getting this? Pretty easy, right? Pretty easy. 6. All right, now I'm going to make it a wee bit harder. What if I gave you 7? Okay, what if I gave you this? X plus 4 squared equals, I don't know, equals 49. So this is where we're going to be moving into seeing things like this more often. And so when you see it, you got to know what to do. It looks confusing, but look, notice this blob is being squared, right? When I could square root this blob, and all I would have left is x plus 4. Because really, think about it. What is x plus 4 squared? That is x plus 4 times x plus 4. Do you guys agree with me? Right? And the square, if I square rooted that, I'm asking myself, what does square root say? It says, what number times itself equals x plus 4? Equals x plus 4 squared. Well, x plus 4 times x plus 4. Therefore, they come out as an x plus 4. Yes?
Yeah.
You with me?
Yeah.
Did I lose anybody?
No.
So, if that had been x squared, and I square root it, it's x. If it's x plus 4 squared, then when I square root it, I get x plus 4. Right? All the square root does is it gets rid of the square. Square root and square are opposite operations. Right? Like, you know how like division is opposite of multiplication, and addition is opposite of subtraction? Well, squares and square roots are opposite. So if you have something being squared, if you square root it, it just gets, the square root and the square just disappear. So technically, these two things just disappeared. And all you have left is that. Okay? All right. And then what do I have over here? Equals.
And then 7. 49.
Plus or minus 7. All right? That's what I was waiting for. I was just waiting for the plus or minus, right? That's all. You got to make sure you always give the plus or minus for this side. Okay? Now, how do I solve for x? This is the tricky part. Yeah, Isla. Subtract 4, but what do I have on this side? I have two different answers. I have a positive 7 or a negative 7. So now I have two problems. I've got x plus 4 equals positive 7 or x plus 4 equals negative 7. You with me?
Is this going to be on the homework?
Yeah.
Okay.
Yeah. Right? It's not that hard. You just have to realize, when you have something like this where you have to subtract things, then to get x, you've got two answers. You're going to have two answers. So we're going to subtract 4. And that gives me x equals 3. Or subtract 4, and x is equal to 11. Right? Excuse me, negative 11. Right? Make sense? Yes? Did you write this down?
Yeah.
In your notes? Okay. 7, 8. Let's try a few of those so that you get really comfortable with them. 8. What if I gave you x minus 6 squared is equal to, 25? What would I do?
Okay, don't you square root x minus 6?
Yes. I'm going to square root this side, square root this side.
That side, so x equals 5.
X
So
minus
x
6
equals 5.
plus or minus 5.
5.
And now I've got to I want to add 6 to both sides, but I've got two answers over here, so I got to set it up as two equations. So x minus 6 is equal to 5, or x minus 6 is equal to negative 5. And now what do I do?
Plus 6.
Plus 6, plus 6, plus 6, plus 6.
So that's x.
So x is equal to 11, or x is equal to 1, right?
Correct.
Make sense?
Yeah.
All right, I think that's about as hard as it gets. Let me just see. Let's do, actually not quite, there's one more. 7, 8, 9, last one, I think. Where did I do it? Oh, there. All right. What am I on, 9? What if I gave you this? 3x plus 5. This one is on the homework. Is equal to 25.
This one is on there?
This one is on the homework.
Oh.
This is number 15 on the homework.
15.
What would I do? What would I do?
You'd square it by, you just square it.
I could square root both sides, right?
Yeah.
All right, so that gives me, here is just 3x plus 5 is equal to plus or minus 5, right?
Yeah. And then,
So then you have 3x plus 5 is equal to 5, or 3x plus 5 is equal to negative 5. We got to subtract 5, subtract 5. 3x is equal to what?
oh, I see.
0. But I want to know what x is.
Yes, you have to divide.
Divide by 3, and I know x is 0. Now this one is interesting. 3 times x equals 0. When a number times a number equals 0, one of them has to be 0. Well, the 3 is not 0, obviously, so x has to be 0. Does that make sense? Right? And then this one, we're going to subtract 5, and I have 3x is equal to negative 10. I've got to divide by 3, x is equal to negative 10/3. Right? So you might have a fraction as an answer. It's okay. Okay? Make sense? I hope I didn't.
Are you serious? Is there another one?
Well, there's just one other thing. What if I gave you, sorry, there is one more thing. I'm getting you guys ready for lots of things in the future, right? But it's great because this is so simple, right? So I'm teaching a lot of things in a simple context. Does that make sense? And it'll make a difference.
Sorry.
All right, 9, 10. Last one, I hope. All right, here we go. 9, 10. Here we go. What if I gave you this? X minus 2 squared is equal to 11.
Oh,
Ooh.
okay, well you square root both of them.
Okay, so, yeah, Micah says square root both sides. You were right.
Randomly.
Square, this is on the homework, this type of one. Square root both sides.
X minus 2.
So I've got x minus 2 is equal to,
You do a decimal.
don't bother, keep it as the square root of 11. So it's just plus or minus the square root of 11. And these are actually easier than the others because what do I have to do now to get us to say x equals? Add 2. So if I add 2 to both sides, I can't add it to this, right? So I'm going to just keep this, and I'm going to go say this. X is equal to 2 plus or minus the square root of 11. And I know that's a weird answer, but that is an acceptable answer. If this is the precise answer, if I wanted to know what this approximately was, I'd get out my calculator, and I'd type 11 square root, and I'd get a number there, and I'd add 2 to it, right? And then I'd do negative that number and add 2 to it, right? So I could do that if I wanted. But this is the accurate answer. If I took this, if I got an approximate answer of the square root of 11, it would be an approximate answer. Does that make sense? Fist of 5. You guys clear on this? Did I lose you guys
No, I
on the
get it.
last
No,
one?
I got you.
Really? Okay. All right. So I'm going to stop this.